Hey everybody, so today I want to talk a little bit about states of matter, phases of matter, phase changes, and energy changes in matter. So first thing I'm going to start with is states of matter. So let's see if I can get this on the screen for you guys. Technical difficulties here. And rotate it. There we go. Okay. So we're going to talk about the four states of matter very briefly. This should all be very familiar to you. So we have our solids. We have our liquids. We have our gases. And we have plasma. Those are our four states of matter. So some characteristics of each state of matter. First of all, solids have, if I can write, definite shape and definite volume. Definite shape and definite volume. They are also incompressible, so they can't be compressed. Very little energy between the atoms. Very little energy between atoms. You can say the atoms are tightly bound to one another. Liquids, on the other hand, have no definite shape, but they do have a definite volume. I'm sure you guys remember that a liquid is going to take the shape of whatever container it is placed in. It has, or they have, more energy than solids. So their atoms have more room to move around and flow on top of one another. The main things when it comes to liquids. Gas, on the other hand, these guys, or gases I should say, are compressible. I'm going to put a question mark whether I spelled that right. I'm a terrible speller. So gases are compressible. They have no definite shape and no definite volume. They have more energy between atoms than liquids. Last thing, I'll put it down here. They will completely fill whatever container they are in. So they're going to take the shape, they're going to take the volume of whatever container they're in. So take shape and volume of whatever container they're in. Okay, so compressible, no definite shape, no definite volume, definitely more energy between the atoms. It allows the increased amount of energy between liquids and gases allow the gas molecules or atoms to spread out and get as far away from one another as possible. Take the shape and volume of whatever container they're in. Okay, plasmas are basically, they are high energy gases. I mean, basically. Way more energy between their atoms or molecules than gases. You're going to find plasmas in like the core of the sun and stars, plasma TVs, some signs, some kind of those neon signs, some of them actually are composed of plasma. The thing about plasmas are there are such high energy between the atoms that make them up that the atoms move around and they are flying around at such a high speed that they're going to knock into each other, and they are going to actually literally knock out some of the electrons from the atoms, causing the substance to be what we call ionized, or having these charged particles floating around. So high energy gas is basically what it is. So particles move around so fast, they knock into each other and knock out their electrons. So particles become charged. So you've got all these negative electrons floating around, and then you've got all of these atoms that have these positive charges to them. That is a very brief rundown of our 4 states of matter and some of their characteristics. Okay, moving on. I do want to talk a little bit about phases of matter, because your assignment actually discusses phases of matter, and I want to tell you the difference between a phase of matter and a state of matter. So, phase of matter. So a phase of matter is a section of matter that looks all the same. So a section of matter that looks all the same. So a phase of matter and a state of matter are quite a bit different. So let me give you an example here. So if we have a beaker, and let's say I put some water in the beaker, and then I put some oil inside of that beaker. If you guys remember, oil is less dense than water, and it is going to float. So we have 2 phases of matter. We have our section of water that is all the same. So this is going to be one phase. And then we have our section of matter, all of the oil, okay, is all going to look the same. And that is another phase. Okay, so right now we have 2 phases of matter. Okay, however, both of our phases are both liquid. So even though we have one and 2 phases, I'll say 2 phases, we actually only have 1 state of matter. So 2 phases, we have the oil section, we have the water section, but only 1 state of matter because both of them are liquid. Another example, so if I took a beaker and I put water into it, and then I drop some sand into it. Sand is insoluble, so all of our sand is going to sink to the bottom. Again, we have 2 phases of matter. We have our water phase. This is a phase. And then we've got our sand phase. That's another phase. So we have 2 phases. But we also have 2 states of matter. So since my sand is solid, okay, that is 1 state of matter. And since my water is liquid, that's another state of matter. So a phase of matter and a state of matter are 2 different things. Phase of matter is a section of matter that looks all of the same, but a state of matter is going to be one of those 4 states that I just talked about: solid, liquids, or gases. And that's going to be very helpful for one of your assignments today. So hopefully that clarifies the very end. Okay, got a little bit more to talk about. The next thing I want to discuss is I want to discuss energy changes in matter. So energy, see if I can get so you guys can write when I'm writing. So energy changes in matter. Okay, so two types of energy changes, and I'm sure you guys have heard this before. I think biology, we might have discussed them a little bit. We had endothermic. Oh, let's try that again. Endothermic changes, and we have exothermic changes in matter. Endothermic means energy is being absorbed. So energy is absorbed into the change. Exothermic, exo, exit, so energy is released. These changes in matter happen in physical and chemical changes. In chemical changes, if it's an endothermic change, a lot of times the container is going to get cold. That kind of tips you off. And I'm talking about a chemical change. So if it's a chemical change and you put some chemicals into a vessel of some sort, and the vessel gets cold or the container gets cold, that gives you an idea that it's an endothermic change. Energy has to be brought into the chemical reaction or the chemical change, and since it is brought in from the environment, then the environment or the vessel is going to get cold. Exothermic, in chemical changes, your container is going to get warm, or it might get hot. Okay. You'll see several of these. You'll see both of these for sure, actually, when we do the chemical and physical changes lab. So endothermic changes, energy is absorbed into the change. And again, this could be physical or chemical. I gave you some examples of chemical, and we're going to talk about physical changes in just a second. Exothermic, energy is released. If it's chemical change, the container is going to get warm, and that's going to kind of tip you off to the idea that it's actually an exothermic change. So looking at these endothermic and exothermic changes, I want to look at phase changes or state of matter changes and talk about a little bit how these guys come into play when we're talking about phase changes. So a phase change is also known as a state of matter change. See if I can get this all on one sheet of paper. Okay, so I'm going to start down here, and I am going to make myself a solid. I'm going to make myself a liquid, and I'm going to put a gas up here. I'm going to make my particles of the gas very far apart. I'm going to put these little things so it looks like they're going super fast. Liquids, the particles are a little bit closer because they have less energy between them. So if you don't have very much energy, you're not going to be able to move around very much, and you're not going to be able to spread out. Solids, the atoms, like I discussed before, are super tightly packed. Solids are incompressible. Jeez, I might have to Google that. Somebody might have to Google that. So this kind of gives you an idea of what the particles look like in these three states of matter. So what we're going to look at is phase changes and how energy changes play into each phase change. So let's see, I'll stick with blue. I'll do my phase changes. I'll do my phase changes in light blue. So I'll make myself a little key over here. I'll make it in light blue. Phase changes are in light blue. Okay, so we'll start with solid to liquid. So if a substance goes from a solid to liquid, that's melting. Easy enough. If something goes from a liquid back to a solid, that's freezing. So again, we're going to start with phase changes. If something goes from I'm going to go from a gas to a liquid. That's called condensation. I'm sure you guys have seen that before. If you get a warm glass, pour ice and water into it on the outside of the glass, it gets very wet and you see droplets. That's condensation. If I am going, and I try to leave a little bit of room, if I'm going from a liquid to a gas, this has two names. So this phase change or state of matter change from a liquid to a gas goes by two things. It goes by evaporation or vaporization. Okay, the difference between those two is vaporization happens at the boiling point of the substance. So like if I had a beaker of salt water, then I put it on the hot plate, I turn it on, the water hits its boiling point, 100 degrees Celsius, and it changes from a liquid to a gas. Evaporation, this is the state change, but not, or the phase change, not at boiling point. So evaporation, the state change occurs, or phase change occurs from liquid to gas, but not at the boiling point. Vaporization, the substance hits its boiling point and then changes from a liquid to a gas. If we are going from a solid to a gas, that's called sublimation. Dry ice does that. So if you've ever gone to a Halloween party and they brought dry ice and put it into some punch, it turns directly from a solid into a gas, skips that liquid stage. And then our last one, gas to a solid, is called deposition. I think my handwriting is getting progressively better. Deposition. Deposition, there's not too many substances that do this, but up in the clouds, when we get sleet or snow, a lot of times this phase change occurs up there. Okay, so these are our phase changes or state of matter changes. So we've got 6 of them: sublimation, deposition, freezing, melting, evaporation / vaporization, and condensation. Now for each of these changes to occur, there has to either be an input or an output of energy. And again, all of these state of matter changes, these are all physical changes. Okay, no new substances are being made. So I'm going to make my little key up here. I'm going to make red, and red is going to represent my energy changes. Okay. So I'm just going to label as endothermic or exothermic. So endo or exo. So if you can see, my solid particles, the particles that make up the solid are very tightly packed. Liquid, they're a little bit further away. So obviously there has to be more energy between the particles that make up a liquid than a solid. Okay, so in order to get our solid to turn into a liquid, we have to absorb energy. Energy has to be absorbed, so this is going to be endothermic. Let's try that again. Endothermic. So melting is going to be an endothermic change. On the flip side, if we're going from a liquid to a solid, where obviously the particles have to get closer together, we have to lose energy to have the particles go from further apart to closer together. So energy has to be released. So that's going to be an exothermic change. Vaporization, so as the particles go from kind of far apart to really far apart, energy has to be put into the system, or energy has to be put into the substance to get our particles to have more energy to move around much faster, and to spread out and use the entire container. So evaporation or vaporization is going to be an endothermic change. On the flip side, if we're going from a gas to a liquid, we're going from high energy particles very far apart, moving very quickly, and then they get closer and closer together. So energy is going to have to be released to go from a gas to a liquid for condensation. So that's going to be exothermic. I'm sure you can guess by now, if I'm going directly from a solid to a gas, we go from the atoms that are super tightly packed to very, very far apart. There's definitely a lot more energy between these molecules or these atoms versus these. So energy is going to have to be put into the system or put into the substance in order to get our particles to move faster and much further apart. So sublimation is going to be an endothermic change. And last but not least, we go from a gas that is high energy to a solid that has very little energy between the atoms, tightly packed, they're barely vibrating. So energy has to come out in order for the atoms to get closer together and kind of be that tightly packed. So that's going to be an exothermic change. Okay, I will scan these and put these on Google Classroom, so you guys have, in case I went a little too fast, obviously you can replay the video at any time, but also put my diagrams and my notes on Google Classroom. Okay, you guys, hope you guys have a wonderful day. Miss you, and be good for the sub. Take care. Bye.